Hello students, in today's video we will learn how to draw the graph of sin x, sin 2x and 2 sin x. This topic is based on graph of trigonometry functions of class 11, both ISC as well as CBSC. Now if we know the graph of sin x, we can easily draw the graph of sin 2x and 2 sin x with respect to sin x. So before drawing the graph of sin 2x and 2 sin x, we need to draw the graph of sin x. And for drawing the graph of sin x, we need to know the range of sin x and the period of sin x. Now here sin x is a trigonometric function. Now what is the range of sin x, range of this trigonometric function? So domain is all real numbers. Sine always gives a real value for x, for any real number, but the range is between a specific value. So the range of sin x is actually closed interval -1 to 1. That means the value of sin x is going to be minimum -1 and it's going to be maximum +1. The meaning of closed interval over here, that is a square bracket, the meaning of closed interval over here is that -1 and +1, both the values are included. Now it is important to know period. Now as we know that all the trigonometric functions, that is sin x, cos x, tan x, cosec x, cot x, sec x, all these trigonometric functions are periodic functions. The meaning of the word periodic means something which repeats after a specific interval of time. So sin x repeats its design after a specific interval of time. So the period of sin x is 2 pi. That means after 2 pi radian, the graph of sin x repeats itself, the design repeats itself. That is the meaning of period. So if we draw the graph of sin x, it will become something like this. This is the y-axis, and this is the x-axis. So in the y-axis, we have the values of the range. So let us put 1 over here and let us put -1 over here, which indicates that the value of sine will range between -1 to 1. On the x-axis, we'll start with 0, then we will put pi by 2. Let me increase the space, so it's pi by 2, then it's going to be pi, then it's going to be 3 pi by 2, then it's going to be 2 pi. So I want to draw the graph of sin x for its entire period. Now if we find out the values of sin x at these various points, we will see that sin 0 is actually 0. So let me take a different color. For example, for sin x, let me take green. So the value of sin 0 is 0. The value of sin pi by 2, that is 1, that is 90, sin 90 is 1. The value of sin pi is again 0. The value of sin 3 pi by 2, which is sin 270 degrees, -1, and the value of sin 2 pi is 0 again. So what I will do, I will first of all draw a fine line for this 1 and -1, so that my graph doesn't move out of this boundary. So now if I draw the graph of sine, it will appear somewhat like this. This is a freehand diagram that I'm drawing, guys, so it might be little inaccurate. However, the values will definitely touch its correct points. So this particular graph is of sine x. Okay, now you can see that after 2 pi this graph is going to repeat itself, so it's again going to repeat the same design that we have from 0 to 2 pi. That is the reason why 2 pi is called the period of sine x function, because after 2 pi it is going to repeat the design. However, we will stop at 2 pi. Now next we will draw the graph of uh, sine 2 pi, sine 2x. Now what is the physical significance of sine 2x, that we need to know. Otherwise we will have to take different values of x, okay, maybe multiple, maybe 10-20 values of x till 2 pi, or whatever is the period of sine 2x, we will have to take that uh, up to that value we have to take different values of x, and we have to find out different values of sine 2x, and then we have to plot and then draw a graph. So that will be a hectic task. However, there is a shortcut to analyze sine 2x with respect to sine x and draw its graph. You have to see this particular value, that is sine 2x. So earlier it was sine x, now 2x. So what does that mean? So as you know that x is the horizontal axis and y is the vertical axis. Now sine 2x means that sine 2x is going to reach the same heights as sine x, but at half the time or half the radian values. This is the physical significance of sine 2x, that sine 2x is going to reach. So you can imagine like this, that sine 2x has double the speed of sine x. Sine 2x has double the speed of sine x. So in whatever value sine x has reached at the y-axis, sine 2x is going to reach those same values, but at half the distance. So if sine 2x, so here we can see that at pi by 2 sine x has achieved 1. That means sine 2x is going to achieve the same value 1, but at half the distance on the y-axis. That means at pi by 4. At pi by 4. Now I calculated this, I set this pi by 4 right from this particular approximation, that since it is sine 2x, that means 2x, you can consider 2x as the speed. So sine x is traveling at x speed and sine 2x is traveling at 2x speed. So sine 2x is able to reach the same y values as sine x, but at half the distance on the x-axis. So if sine x is able to reach 1 at pi by 2, then sine 2x will be able to reach 1 but at pi by 4. So if I put the value of sine 2 into pi by 4, that is the value of x as taken as pi by 4, you will see we get sine pi by 2, which is 1. So that means at pi by 4 sine 2x is going to reach this 1. Then what is going to happen? What about pi then? So at pi sine x reached 0 value. So that means sine 2x is going to reach that 0 value. So you can see that at pi sine x, what is the value of sine x? What is the value of sine pi? It is 0. So that means that x equals to pi, sine has reached 0 value. So sine 2x is going to reach 0 value, but at half the distance. So that means it is going to be pi by 2. So that means sine 2x is going to touch pi by 2, touch 0 at pi by 2. Then what about 3 pi by 4? 3 pi by 2. So we see that sine x touch at 3 pi by 2 touches minus 1. Sine x at 3 pi by 2 touches minus 1. So that means sine 2x is going to touch minus 1 at half of 3 pi by 2, which is 3 pi by 4. And 3 pi by 4 is a value that comes over here, 3 pi by 4. Okay, so it is going to touch this particular point. What about 2 pi then? So sine x has touched 0 value at 2 pi. Sine x has touched 0 value at 2 pi. So sine 2x is going to touch 0 value, but at half the distance of 2 pi. So that means it is going to be pi, which is this. So if I draw the graph of sine 2x, it will be like this. So it will go touch like this, then it will come like this, and then it will reach like this, and then it will go like this. Yeah, so you can see that the entire graph of sine x has been squeezed within 0 to pi, which is nothing but sine pi by 2. However, if you see that the height of sine x and sine 2x, both of them are same. It is touching this 1 and minus 1. So that means sine 2x is going to reach the same heights as sine x, but at half the distance on the x-axis. Now if you notice that sine 2x is going to repeat its design after pi, right? This is the place where sine, this is the place from where sine 2x is again rising in upward direction and is going to repeat the design. So that means, and since we have learned earlier that the angle value, the radian value after which a graph repeats its design is called a period. Therefore from here we can we can deduce that period of sine 2x is pi, and that is what the formula also tells. So in most of the books such as M.L. Agarwal, R.D. Sharma, you will find it, there is a formula written that the if the period of sine x is 2 pi, then the period of sine 2x will be 2 pi by whatever is the coefficient of x, which is pi, but and that is going to be 2 pi by 2, which is pi. But the question is that how did it come up? So this is the way that you can prove that why the period of sine 2x is pi. We have drawn the graph of sine x, and based on sine x we have drawn sine 2x. Sine 2x is going to reach the same destination but at half the distance, and we can see that after pi it is going to repeat the design, therefore pi is the period of sine 2x. Okay, so now let us move to 2 sin x. Let me take a different color, this time maybe okay, blue. So let me take, now let us try to draw the graph of 2 sin x. So 2 sin x is very easy. If you see, 2 sin x is just double of sin x. 2 sin x is just double of sin x. So that means 2 sin x is going to reach double the heights of sin x but at the same distance. So that means if sin x at pi by 2 has reached 1, then that means 2 sin x at pi by 2 is going to reach 2. Why? Because at x equals to pi by 2, 2 sin x is 2 into 1, that is 2. So 2 sin x, that means when the number is in front, okay, then that only doubles the height at which doubles the height of sin x. So there will be no change in the x axis, so it will still remain pi by 2, pi, 3 pi by 2 and 2 pi, but the heights will increase. So that means I have to plot a 2 over here and I have to plot a 2 over here, minus 2 over here, sorry, 2 and minus 2. So in that case we can say that the range of, so let me write it over here, I can write it over here. So that means I can say that the range of 2 sin x is minus 2 to 2. Why? Because the range of sin x was minus 1 to 1, so the range of 2 sin x is minus 2 to 2. So let me draw a fine line. Sorry. Okay, so now let us, so we are going to touch the same points. Okay, we are going to touch the same points. So it will be somewhat like this, go like this, and then at pi it is going to cut 0. So the design is going to be the same thing. There is no change in the x-axis. Why no change in the x-axis? Because you see here also we have x, here also we have x. Only the y-axis is getting doubled since there is 2 in front, and it is going to go like this. And then it is going to go like this. So this is the graph of 2 sin x. Now as you can see that since after 2 pi it is going to repeat the design, since after 2 pi 2 sin x is going to repeat the design, therefore we say that the period of 2 sin x is still 2 pi. The period is still 2 pi. Why? Because after 2 pi radian 2 sin x is going to repeat its design. So in today's video we will stop till here. In our next video we will see that how we can draw graphs of sine square x and sine x minus pi by 4 or sine x plus pi by 4 with respect to sine x.